All right, we are live. Let me just get it all set up. Gotta pop out the chat. All right, we are all set to go. So it's not COVID. I did a test. I know it's not COVID. Doesn't mean that I'm happy with having a bit of a cold or whatever it might be. So we'll see how it develops and we'll see how long I can go today. But you guys know what to do. If you're just getting here, we did just start, so feel free to ask your questions. If you don't have questions, just like the live. We can get more people in here that way. Did I see the meteor in Panama? I didn't. What would happen if you launched a Crunchwrap Supreme into the sun? Well, it would burn up. How many engineers does it take to change a light bulb? Hopefully one. Do you think the universe was designed? I don't. Can you explain what happened with traveling back in time 1 second? I don't know what you're referring to. None the text do all the work. That's funny. That's a good point. Can you explain why there's different sized infinities? Yeah, so the way that we compare sets, so when we talk about the size of infinity, what we're talking about is the size of sets. And so if you, the way that we compare set sizes is we say, when can you put this set in a one-to-one correspondence with that set? Or rather, when can every element of this set be mapped into that set? Or vice versa. And the thing about that is that it works well. Like if you have a set of 5 elements and a set of four elements, then every set or every element in the set of four elements can be mapped on to something in the set of 5 elements, but not the other way around, at least not uniquely. And so we would say that the set of 5 elements has more elements than the set of 4 elements. But when we're talking about infinite sets, now you do the same thing, but you have to be a little bit cleverer because it just takes a little bit of work to do. But importantly, for example, you can map every integer, 1, 2, 3, or let's say every positive integer, 1, 2, 3, 4, 5, all the way up to infinity. You can map those onto the even integers. You map 1 to 2, 2 to 4, 3 to 6, and so on, and each one will be hit. And so we say that the infinities of the size of the infinities that make up the even integers is the same as the size of infinities as the integers. But the real numbers, all of the numbers with all of the infinitesimal expansions, you can't do that with the integers, for example. So we would say that the real numbers, this is all of the numbers with decimals and so on, those things, there's more of those than there are integers, for example. Are you being a physicist right now? I mean, I'm doing science communication. I consider it part of the job. What is your opinion on the Great Attractor? Could it leave evidence for God? Not really. It's almost certainly just a whole bunch of galaxies that we just can't see because they're being blocked by our galaxy. They claim to have used a quantum system to travel back in time with a quantum computer. Yeah, I'd be skeptical of any claims like that. Do you believe it could be possible to travel back in time? It's like in principle possible, but probably not with the facts of our universe, no. How many different sizes of infinity are there? There's an infinite number. And I think it's actually an uncountably infinite number. Could the known universe, 13.8 billion years, be inside a black hole? Almost certainly not if general relativity is true. And I think I have a proof that this is the case, but I haven't written it up yet. Any update on 3i Atlas? It's a comet. It's a comet. It's a weird comet, but it's a comet. How many satellites would it take to communicate to Andromeda? Well, essentially you just need one really big one. In theory, could something like the Flash happen, the particle accelerated explosion causing mutants? Not really, no. It's not really a thing. Why do we insist quantities like Lagrangian densities and QFT are local functions, first derivatives? Well, because we kind of expect things to only influence their surroundings, right? That's the gist of it. Is the rate of expansion of the universe greater than the speed of light? They're not really things that you can compare. So the speed of light is a speed in meters per second. The rate of expansion of the universe is not a speed in meters per second or in miles per hour. It is a doubling time. So the universe doubles in size about once every 10 billion years. If Jupiter acquired enough mass to ignite, what would happen to the Earth? Well, the Earth's orbit would change dramatically. We're not so close to Jupiter that I don't think it would like fry the Earth, but we would get like twice as much light, or more light anyway. So it would probably not be great. I want to be an astrophysicist. What steps can I take now to ensure that? Go to school and get good grades. That's the first step. Where does the mass of a hadron come from? I'm aware it's from the gluons, but is it the gluon's energy? Yes, it's the gluon's energy. Are you writing a book? Have you wrote one? No, I'm not. I think too many people write books these days. That's my view anyway. Are we in a black hole? Probably not. I suspect not. I heard we were able to stop time on atoms. Do you think that we could ever use quantum entanglement on... There's the rest of the question. But no, I don't think that that's true. I mean, we can look into it, but I suspect that anything that you've heard that says that we stop time or reverse time, be very, very skeptical of those claims. Almost certainly it's like, oh, we did something so that if time were stopped, it would look like this, When will anti-gravity be found? Well, in some sense, we've already found it. That's what dark energy is. But it's not really a thing that you can, make, at least as far as we can tell. How do you synthesize a methylated alkaloid? I don't know. I'm not a chemist. I understand the expansion of the universe is faster than the speed of light and speeding up. It's not. This expansion of the universe is not something that makes sense to say has a speed. It doesn't, speeds are things in units of meters per second or miles per hour or kilometers per hour or whatever. The expansion of the universe doesn't have that. If you fell in a black hole, what would happen? So it really depends on the size of the black hole. If it's a big black hole, like a supermassive black hole, you wouldn't even notice that you fall in. I mean, you would notice, but you'd be fine. You'd be fine as you cross the event horizon. You still wouldn't be able to get out, but eventually you would get closer and closer to the singularity, and then you would be torn to shreds. However, for a stellar mass black hole, a black hole that's kind of like normal formed from a star, those black holes will probably tear you up before you get to the event horizon, just because the tides are so strong. Can you explain to me why acceleration is proportional to displacement in a simple harmonic oscillator, in a simple harmonic motion? That just has to do with the way that the motion is, that just has to do with the origins of the force, right? So essentially what's happening is that the more if we're talking about a spring, right? The more the spring is stretched, well, how do I want to put this? The bending of the spring is the amount that each piece of wire in the spring is bent is going to be proportional to the length that it's stretched by. And the force is proportional to how bent, how deformed away from equilibrium the spring is going to be. And so you'll end up with a force that is proportional to the amount that the spring is stretched, and the force is proportional to acceleration from Newton's second law. Did you check to see if the University of Iowa is hiring? I think Quantonaut went there. I haven't checked, but maybe I will. From Ant with the $10. Thank you so much. No question. Go do good science. RHFD. I don't know what that means, but thank you. I appreciate that. But I'm going to do this for an hour and a half, and then I'll go do some science. Did they figure out yet how all superconductors work? No, that's still, there are models, but we still don't know enough that we can predict which things will be superconductors, because it's really complicated. What's in a black hole? Well, in some sense we don't really know, but we can sort of guess. So if we trust general relativity, which is our best theory of gravity, then there's a singularity, a point of infinite density and infinite space-time curvature. Oh, rock hard for Doug, that's right. Okay, thank you. On the other hand, most people don't trust general relativity to that extent, and so instead, a lot of people have different ideas, that there might be some ultra-dense core that's still not infinitely dense and so on. So it's not clear. You motherfucker, you are not a physicist. I am. That's what the publications would indicate. That's what my PhD would indicate, but okay. Why are certain PDEs unsolvable analytically, like Navier-Stokes? Well, the thing is most PDEs are unsolvable analytically. Just think of I think that you're coming at this from the assumption that things should be solvable analytically. Most things are not solvable analytically. If you give me a random polynomial, I will not be able to give you a closed form solution for the zeros. That's just a fact, right? Most things don't have analytic solutions. It's only the nice things that do. How did Newton measure gravitational constant so long ago? He actually didn't measure it. That wasn't until Henry Cavendish, that actually measured the gravitational constant. He just proposed that there was a constant. Superposition is so weird it stops when you see it. Well, I mean, it's not really like that. It stops when you interact with it. Definitely. What is the page time of a black hole? The page time is related to the time when the entropy of the black hole starts decreasing, if I remember correctly. Basically, it's the turnaround point where you start to be able to recover what the system is doing, what the quantum systems that fell in were doing, based off of the Hawking radiation. Peter Kropotkin with the $5. Thank you. In Einstein's rocket elevators, does light bend for different reasons? Elevator passing through straight line and light following a curved path? Well, but those are the same reason. That's the point. What level KeV does cobalt 60 emit? Oh, I don't know. I don't know off the top of my head. What is the event horizon? The event horizon for a black hole is the point of no return. It's once you go past it, you can't leave. You're done. From Larry Beck with the $5, just to keep it up, thank you so much. How come something can have infinite density? I can't wrap my head around that. Well, the thing is I don't think it can, which is why I'm in the camp that general relativity must certainly break down. Is it worth it to become an astrophysicist? Well, look, I'm not an astrophysicist, but if you want to be an astrophysicist, then, I mean, it'll be worth it because you'll be doing what you love. But keep in mind, the money isn't a lot, right? For the amount of school that you do, the money's not a lot. What specifically is my research about? I have a lot of different research topics, but generally things relating to relativity and conformal geometry. What does quantum mechanics mean for the nature of reality? That is a philosophy question. I'm not going to answer that here. Apologize my ignorance. Why does it seem like the pace of advancement of our understanding of the universe has decreased significantly? Oh, well, because it hasn't, right? I mean, this is just something that, like, it's a false narrative. It's not the case that our understanding of the universe has decreased, that the advancement of our understanding of the universe is decreased significantly. Now, what is the case is that, say, in the, I don't know, between 1900 and, say, 1928, there were a lot of breakthroughs, and that's just because essentially that's when we kind of finished mastering electricity, and we finally had the tech to finally study things that were within our reach in a real legitimate way. So it is true that between the period of 1900 and, say, 1930 maybe, the amount of breakthroughs was much more than it had been in the past and has been since. But that was the out of the ordinary thing. Prior to then, the rate of discovery was about the same as it is now. In fact, arguably it's faster now than it was in the past. And from Forum Galorum with the $5, do you ever use your physics superpower to win games of billiards as a pool shark? I would hope. I've tried that, but it requires dexterity as well as knowledge, right? Did you see Jeff Bezos' testimony about trying to be a physicist? Yeah, I've heard about that. It's kind of funny. Do you think we will find proof of supersymmetry, or do you believe it doesn't exist? I kind of lean towards it not existing, right? Like, maybe it exists. Maybe we just need to build a bigger and bigger collider. But, like, can we bend space-time in a loop and go back in time? Well, so it's, like, allowed by the math, but almost certainly it's not possible given the universe that we live in. If you don't die in a black hole, what will happen? Well, you will die. There's no ifs, ands, or buts about it. How much experience in coding did you have before your undergrad? Oh, I was fluent in Java before I started my undergrad. Was Einstein an atheist? If he wasn't an atheist, he certainly didn't believe in a personal God. It's not clear that he even believed in, like, a non-personal God. He definitely thought that religion was silly. Given a harmonic potential, what happens when a particle tunnels in the potential? Does it increase in energy? No, so it can only tunnel to places where it has enough energy to exist. It can't tunnel to a location where its kinetic energy would be negative. Do the breakthroughs in AI help in your field, and how? Not really. AI has not been particularly helpful in actually doing physics, or mathematics for that matter. Well, okay, I should say, there are some things in mathematics that I guess it's been helpful for, but not in the stuff that I do. What are primordial black holes? A primordial black hole is hypothetical. We don't know if they exist, but if they do exist, they would be black holes that formed just by matter being really, really dense in the early universe, like seconds after the Big Bang. What is cosmic perspective and what does it mean? I don't know what you mean by that, but by the way, if you're spamming, please don't. I will mute you. If you're repeating the same question over and over again, like, put some time between them, okay? Why can't I get a toaster that's see-through so I can see how it's cooking? I guess in principle you could, but it might melt, because most see-through things, I guess you could get one out of glass, right? William Polk with the $2. How do you get ice in an ice bottle? You put the water in and then freeze it. Was Newton more brilliant than Einstein? Debatable. Can entropy locally decrease without violating the second law? Absolutely. Yeah, absolutely. How do quarks work? I just find particles smaller than electrons hard to comprehend. So quarks aren't smaller than electrons. Quarks and electrons are equally zero size, or rather, they're equally point particles. What that means is that they don't have a specific size, at least as far as we can tell. Wouldn't you have to be outside of space and time to bend it? No, I mean, stars bend space-time, and they're not outside of space-time. Is the audio low, or is it just me? Is the audio low? No, I think it's just you, actually, because the audio is almost peaking. Objects move in a straight line in 4 dimensions, but in 3 dimensions, we can't see them. We can't see them moving in curve. I don't understand what the question means. How can light be affected by gravity if it doesn't have mass? Right, so light is affected by gravity because gravity is a change in the shape of spacetime, and light travels through spacetime, so it's going to be affected by that change in shape. Newton defo smarter than Newton. Look at all the things Newton did before the age of 30. So you meant Newton is smarter than Einstein. All of Einstein's 4 big breakthroughs, his annus mirabilis, he did when he was 26. So special relativity, E equals mc squared, Brownian motion, and the photoelectric effect, all of which would warrant a Nobel Prize, he did when he was 26 in a single year. So, you know. Are symmetries complex space-time geometry structures? Not necessarily. They're not necessarily structures of space-time. They could be structures of what you might call auxiliary manifolds. Are all the particles in the standard model points? Is that the purpose of QFT? Yeah, basically. Do you think I'd need coding to be a physicist nowadays, considering the development of AI? I mean, most physicists will use coding of some kind. It depends on the kind of physicist, but almost certainly, yeah. But it's not because of AI. What properties does spacetime have for it to bend? Well, it has a, you might call it like an elasticity to it. It can, and as a result, it can actually transmit waves, for example. Please tell me about the double slit experiment. Are we really in control of reality? No, the double slit experiment's really not that unusual. You have something that's quantum, and it's in one way. Sorry, I have to sneeze. You have a quantum thing that's in a superposition, and then you interact with it, and it's not in a superposition anymore because you interacted with it. You changed it, so of course it's going to be different. Would a high energy proton hitting my eyeball cause a flash in my vision? I suppose it could. Einstein could have earned multiple Nobel Prizes if he weren't so lazy. It was almost certainly because he was Jewish, actually. Like, that's the reality of it. Can you explain the math of a black hole? Yeah, I actually have a few videos on this that you could go watch in my general relativity and in my relativity and gravity playlist. So I would check that out because I actually do the math explicitly. Yeah, so generally speaking, the math is something called differential geometry. And the story is basically you investigate, according to Einstein's field equations, what shape space can have given certain phenomena. Like, suppose that there's no matter around the black hole. What would the space-time, how would the space-time be curved? Why wouldn't a car work that gets pulled by a magnet in front of it, but also attached to the car? Well, so the magnet would pull the car, but by the magnet pulling the car is also pulling the magnet. That's Newton's third law. Every force has an equal and opposite reaction. And because the car is attached to the magnet, the car is pulling on itself back in the exact same amount that the magnet is pulling on the car forward. So why can't anything go faster than the speed of light? Well, look, the universe that we live in, there was two different ways it could have been. There could have been a maximum speed, or there could have not been a maximum speed. Our universe happens to have a maximum speed. We don't really have a good explanation as to why that's the case, like what the fundamental reason is. But whatever the maximum speed is, that's going to be the speed of light. It just happens to be that speed. And so just think of it as like, it's not like a cosmic speed limit. It's just the maximum way that you could even like think about what speed is. Several things go faster than the speed of light in a vacuum. That's just the definition of the speed of electromagnetic waves in a vacuum. So the speed of things like light and gravity. No, nothing goes faster than the speed of light in a vacuum. Would farting in space propel you? Yes, yes it could. As long as the gas can escape. Why didn't he win one for GR? Because he was Jewish. Almost certainly because he was Jewish. Essentially, there was a lot of opposition to him winning one at all because he was doing Jewish physics, right? And it took until 16 years after his Annus Mirabilis for him to get a Nobel Prize. So, why is it only interactions that reveal which path information collapse decoherence? You answered it. It's collapse. It's a decoherence thing. In general relativity, bodies follow straight lines in 4D spacetime, but in 3D they don't move curved space. They do move in curved space. If you aim a telescope on Earth at a mirror in space, what will you see? Well, you'll see Earth just a little bit ago. But things observed moving faster than light, being pushed to the speed of light versus merely... I don't think anything's been observed moving faster than the speed of light. So look, so in general relativity, the statement is that things nearby can't move faster than the speed of light, and you can't compare speeds that are distant. So it doesn't make sense to talk about how fast something is moving away from you if it's far away from you already. Why do we define time based on something that can be affected by gravity? Well, we define time based on the way that we define a second anyway is based off of a cesium atom, cesium-137 if I remember correctly. And that particular atom of cesium emits light at a particular frequency. And that's how we define it. Now, the fact of the matter is that all kind of temporal phenomena are affected by gravity, including the cesium atom. But aren't there the theoretical particle tachyons that could go to a higher velocity than light? I mean, no, those aren't, I wouldn't say they're theoretical, I would say they're hypothetical and not really legitimate. Do we know what actually causes electrons to obey the Pauli exclusion principle and how it gets overcome to form a black hole? So we don't know what's going on in a black hole. The Pauli exclusion principle, in some sense, you can think of it as coming from the spin statistics theorem, but that's just kind of pushing the buck back. Like, why does the spin statistics theorem's hypotheses hold? That's a very different question. It's one of these things that's like an observed law of physics, right? Advice for a junior physics major trying to get a summer internship. That, I don't know what the environment's like today as an undergrad. I mean, shoot your shot, I guess. Oh yeah, everybody, make sure to like, share, and subscribe. Do that. If you're on TikTok, the more people that like it, the better. The more questions we can get, the more interesting questions. And share it out. All of these things. Get more people involved. We want more people watching these things. It's good to teach people science. Difference between a field and force. Well, so you can have a force field. A field, though, is just a number or a quantity at every single location in space-time. That's all a field is. Now you can have a field of force vectors. That's totally reasonable. Do you think time is emergent or fundamental? I don't know. Like I'm pretty agnostic on the issue. Is there any material that could theoretically enter a black hole unharmed? Well, yeah. I mean, you could enter a black hole, like a supermassive black hole, unharmed, as long as you have a spacesuit on. Because it's the size of the black hole that makes the event horizon dangerous. Smaller black holes have more dangerous event horizons because the tidal forces are bigger. Can you describe the Higgs boson to me like I'm 5? Yeah, so the Higgs boson is like a water wave in a pool. So the pool is filled with water. If you slap the pool, you'll get a wave out. That's what a Higgs boson is like. But the important thing is the Higgs field is like the water. It's like the water in the pool. And the Higgs field is something that's slowing everything down. Imagine trying to walk through water, walk through a filled pool as opposed to walking through an empty pool. Walking through a filled pool, you'll be slower. And because it slows things down, it effectively gives things mass. Why have we not redefined current as the flow of negative to positive? Because conventions are hard to get rid of. Is the universe slowing down? What do you think about black holes producing dark energy? I think that black holes aren't producing dark energy. I think that that paper is really, really fringe. I think that that result is, I don't know, I'm not so compelled by it. Is the universe's acceleration decreasing? Perhaps. How old were you when you got to the crazy parts of math? It depends on what you call the crazy parts. I got into calculus when I was 14 or 15 or something. If hot air rises, why does it get colder the higher you get? Well, look, so there's a lot of dynamics here, but essentially what's happening is the same reason why you can, so hot air rises, and by rising it expands and cools down, right? That's the way to think about it. Would you recommend someone teaching themselves physics without external help? No, absolutely not. What is negative absolute temperature? Negative absolute temperature is what happens when you have a quantum state or a quantum system that has a finite number of states, and your system is in a higher energy state. It's like higher than half, or rather, it's when you have a whole bunch of quantum particles, each of which has a finite number of quantum states, and they're all in the high energy quantum states. And the reason why this gives you a negative absolute temperature is because one of the ways that we can talk about temperature is it's the rate of change of entropy with respect to energy, or vice versa, depending on whether you want beta or temperature. And the point is that as you increase, if you have a whole bunch of particles that are already in a high energy state, and then you put more energy in, those particles will concentrate even more into the high energy states, which means that the entropy will decrease. So you're adding energy, but the entropy is going down, and so that would give you negative temperature. Why does the universe exist? Maybe because non-existence is impossible. I always like asking physicists if they like Interstellar. So do you? Yeah, I do. I actually originally saw it because my general relativity professor, when I was a senior in undergrad, recommended that everybody in the class go see it. From Forum Galorum with the $2, can we send Elon to Venus instead of Mars? I guess we could, but he'd have to consent, right? Can you explain how the faster you are, the greater the time dilation? Yeah, so the best way to think about this is that moving through space costs you moving through time, right? The faster you move through space, the slower you have to move through time. That's the easiest way to think about it. What was your PhD in? It was in physics, but it was very, very math heavy. If entropy gives time a direction, why do microlaws stay symmetric? That's a good question. It's a hard question that we don't know the answer to. From Single Dive with the $2, do you worry at all about whatever 3i Atlas is? It's a comet. These lives on TikTok are your work or hobbies? So the lives are like 10% of my income or something like this. So you could call it like a side hustle. But I like doing it, right? Did you study anything outside physics? Yeah, I also have a bachelor's degree in mathematics. Thoughts on 3i Atlas? It's comet. How is the Higgs field connected to spacetime? The Higgs field exists everywhere in spacetime, like every other field. But beyond that, it's not like connected to it any more than like the electromagnetic field is. Is it possible for something with mass to travel speed of light, and why? No, it's not possible. That's like one of the fundamental laws of physics that, as far as we can tell, is not being broken. What is glass made from? Like, I know it's heated tiny rocks, but why does it let light through? That I don't know the answer to. You'd have to ask like a chemist or like a condensed matter physicist about that. Is text code math harder than physics math? No. What do you think of the Poincare recurrence theorem? It's great, but it only applies if you have a finite volume, right? Why is physics so perfect it seems to work 100% of the time? Well, it doesn't, but we're good at knowing how to apply it so that it works as well as we need it to work. What's your best interpretation of the equivalence principle? Just that the laws of physics, I mean, the equivalence principle is just that the laws of phrasics are the same in all inertial reference frames, right? Roughly. I mean, I guess there's another way of phrasing it that, or maybe not an equivalent way of phrasing it. I guess another form of the equivalence principle is that inertial mass and gravitational mass are the same. How can space-time bend if it has no properties? Who said space-time doesn't have properties? It has curvature. That's a property. Do you believe quantum computing is possible, and what is its positives other than CPU speed? Quantum computing is possible. We have quantum computers. They exist. The point is that quantum computing can solve particular problems faster than classical computing can. Not all problems, but certain ones. Can you explain G-factor, where it comes from? Please, I'm having a hard time understanding atomic spectroscopy. Probably not. I probably can't explain it in a way that would be helpful to you without going back and referencing my notes from grad school. Because it's been a while since I've thought about it. So I'm going to say no. Maybe I'll make a video about the G-factor or something like that. Just that way then, you know, forces me to relearn the material. G-factor. All right, from Z08840, is it true that if entropy defines the area of time, then in a case of collapsing universe, when entropy is decreasing, we would not notice any difference with current evolution of the universe? Yeah, that is true. As long as the entropy was decreasing during the collapsing universe, yes. From Peter Kropotkin with the $5, well, thank you so much. Would an observer see an elevator travel through a straight light, while the riders see bent light? Yet in the other case, both would agree light bends. What's the other case? So an observer would see the elevator travel through straight light. Yeah. The rider would see bent light. Yes. Yet in the other case, both would agree light bends. I don't know what you mean by the other case. Those are the two cases. Dr. Blitz, why don't more scientists get into politics? We need smarter politicians. Well, they do in other countries. Angela Merkel famously was a nuclear physicist, I think. And the former president of Mexico, what was her name? Something Scheinbaum. She was a former environmental scientist, I think, if I remember correctly. So yeah, in other countries it happens. It's just in the US we don't respect scientists. So make of that what you will. What do you mean quantum computers can't do certain problems as fast? Which ones? No, so quantum computers are equally as good as classical computers for most problems, or at least as far as we can tell, they're equally as good for most problems, but there are certain problems that quantum computers are faster for. So if you want a list of these kinds of things, just look up quantum supremacy problems, and you'll find a list of the kinds of problems that quantum computers are known to be faster at. Claudia Scheinbaum, that's her name, yeah. Can you explain topological matter that Microsoft was bragging about in their quantum computer? I'm not a condensed matter physicist, so I probably won't give an adequate explanation, but essentially there are certain ways that you can arrange matter so that things kind of have to twist around themselves to change states. And so and if you can do this in a kind of quantum way, you can, in some sense, encode quantum bits in these topological states. And so what Microsoft was claiming that they did is they were claiming that they had developed a genuine topological quantum bit. Now that's it's not a holy grail, but it would give it incredible stability for quantum computing. But they were making it up. Nobody took them seriously. Do you lean yes or no on alien life exists? Yes, but almost certainly it hasn't visited us. Oh, so it's less one is best at every and more one is best at most? Well, no, so quantum computing is, as far as we can tell, equivalent to classical computing at most tasks, and quantum computing is better at a few tasks. Classical computing, as far as we can tell, is better at no tasks, because quantum computing can be reduced to classical computing. Like, you can just kind of turn off the quantum pieces, and then you can get classical computing. Why haven't we been visited? Because the universe is very big. And life is pretty rare. Although maybe life isn't rare. I mean, like, you heard I'm sure you heard the announcements from NASA about Mars. So, about the light clock in a traveling spacecraft to explain special relativity. Why is it that the photon seems to be affected by the direction of the spacecraft, even though it has no mass? Why wouldn't it be? Why would mass play a role? Like, it seems super plausible that anything that's moving, if you move relative to it, say perpendicular to it, then it will appear to move at a different angle, right? Is light a wave or a particle? It's a wave. It's definitely a wave, but sometimes it behaves a little bit like a particle. Please help differentiate between angular momentum and linear momentum. Angular momentum is just the momentum associated with rotation. Linear momentum is the momentum associated with translation, moving from point A to point B. That's all. Perhaps you've heard about this emerging theory of radiation ablating being used on hard stones. I've never heard about it, no. I'm bad at math, can I still study physics? I mean, in principle you can, but look, this would be like saying I'm bad at English. I'm bad at reading, can I still study history? Like, yeah, you can, but math is the language of physics. So if you're not fluent, then you're gonna have a hard time. Do you agree that life isn't rare, just its ability to sustain itself is? I mean, like, we don't have any evidence that life is particularly common. I mean, well, okay, maybe we do now that we've potentially found life on Mars. Bro, we got 3 hearings confirming ET are engaging us. Extraordinary claims require extraordinary evidence, and I don't know about you, but I don't really trust politicians generally. So, is the universe eternal, or did it have a beginning? We don't know. I kind of lean towards it being eternal, but I can't say for certain. Do you think that intelligent life have to be in physical form? Like, do you think it's possible for intelligence to exist without a physical body? I suspect not. That seems kind of nonsensical. Theory suggests perhaps Egyptians used ore that are heavy alpha gamma emitters to weaken hard stone. That seems really, really suspect. Give 2 examples of complex numbers being used in real situations. Any sort of AC current modeling, and anything to do with quantum mechanics. So like transistor modeling. So when you're trying to like construct a new transistor, you have to invoke quantum mechanics to do so. And if you're trying to design an electric circuit that has like various AC aspects, complex numbers are indispensable. Good afternoon. Why isn't energy conserved in GR theory? Energy is only conserved in GR when you have a time-like killing vector. Now, a time-like killing vector means that your space-time is stationary. And if your space-time is stationary, then that means that it's not really changing. So, and our universe is changing. Do we need to do all the theorem of math to excel in physics? Not necessarily, but it won't hurt. Thought on Nepal's stuff? I don't know a lot about it. What causes turbulence effects on aircraft? I mean, like, why is it bumpy? I imagine it's just parcels of hot and cold air and wind pointing in different directions and things like that. Could humans live forever one day? I suspect not. But maybe, who knows? How is UW-Madison's physics program? I have no idea. I've never been there. I've never looked into it. If the universe is infinite age size, wouldn't the night sky be filled with nothing but starlight? Only if the universe isn't expanding, only if the stars have existed forever. But if the universe has only had stars for 13.5 billion years, then no. And the universe is expanding. Forum Galorum with the $5. Thank you so much for the generous, generous support. Do white holes exist, or do black holes just release everything through Hawking radiation? Or do they explode? What happens to the mass they absorb? So white holes almost certainly don't exist. If they did, we would see them. They'd be super, super bright, right? White holes are the opposite of black holes. They can only emit light, and they're constantly doing that, constantly emitting stuff. Also, we don't have any reason to think that they could form. Like, there's no proposed mechanism for how white hole would form. So almost certainly white holes don't exist. But yes, the idea is that black holes do eventually release all of the stuff that they absorb in the form of Hawking radiation. And then near the end of their lives, that Hawking radiation emission rate increases until they go off, they kind of like pop at the end. And all of that mass, all of that energy equivalent mass gets released out into the universe. Hey, I had a question about the star that apparently vanished with a supernova. Is that true? I haven't heard about this, so it'd be interesting. Can you explain how gravity contributes to aging? I haven't heard that. I don't think that that's true. I mean, like, in some sense, if you were like orbiting, if you were like high above the Earth where the Earth's gravity is weaker, then in some sense you will live, or I guess you would age more, right? Let me make sure I get the sign right. Yeah, so 1 second for somebody here on Earth is slightly longer than a second for somebody far away from the Earth, and so somebody far away from the Earth will age more relative to somebody on the Earth, but like it's negligible. From Benjamin Phelps with the $10, do you think a cyclical universe could exist, and would other cycles have different laws? It depends on what you mean by cyclical. If by cyclical you mean it's a genuine cycle, well then, I guess in principle it could exist, but it wouldn't have different laws because it has to be the same. However, some people use the word cyclical to refer to kind of a universe that expands and then recollapses, but not necessarily in the same way every time. In which case then maybe, yeah, you do get different laws. Maybe you get that the spontaneous symmetry breaking from the Higgs boson is slightly different each time, or something like that. Do people at the equator age slower than those at other latitudes? Well, the Earth is spinning. I'd have to work at the time dilation effects. But not significantly, no. If there is an effect there, it's not going to be significant. Doc, a question here. I want to become a physicist. Is it really worth it, or should I go engineer? You will have better job prospects as an engineer. That's absolutely true. But you don't go into physics for the money, right? You do it for the love of the game. Do black holes absorb each other's Hawking radiation? Yeah, in principle. But most black holes that exist are emitting so little Hawking radiation that there's not really any hope of detecting it, right? What's the most terrifying physics fact you know? I don't know if any of it's terrifying, but that's because it's all familiar. But okay, well actually here's one that might be kind of terrifying. So there's this idea that the universe might be in what's called a false vacuum state. So the Higgs boson, or the Higgs field rather, is in a particular vacuum state. It's in, it has what's called a non-zero vacuum expectation value, which essentially means that the empty space has some non-zero amount of Higgs field in a technical sense. However, it's possible, as a result of quantum corrections, that there might be an even lower energy state that the Higgs boson could be in, but there's just a barrier between us and it, between where we currently are and it. So like you would have to go, imagine like rolling a ball over a hill to go down into a deeper valley. And so there's this idea that if it's the case that the Higgs boson is in this, or that the Higgs field is in this false vacuum state, then it's possible that the Higgs field could quantum tunnel through that barrier and basically change a significant chunk of the physics kind of spontaneously, and that effect would radiate outwards from the place where it happened and eventually come to us, and we would never see it coming. But you know, you know, if it hasn't happened yet, will it happen? Probably not. Is quantum theory conclusive? The theoretical framework of such large magnitude seems impossible. I don't know what you mean by the theoretical framework of such large magnitude, but quantum physics, more specifically quantum electrodynamics, is the most accurate model of the universe that humans have ever come up with. Like, it makes the most accurate predictions. What moves faster in a vacuum, a photon or a quark? Well, quarks have mass, so they would move slower than the speed of light. Do we know why gravity exists between mass? Well, the best model that we have is that mass causes the curvature of space-time, and that curvature of space-time kind of spreads out from the mass. How much does the rate of Hawking radiation increase with smaller mass? Can very small black holes glow? So at the point where they would be glowing, they would live fractions of a second, right? So it increases super rapidly, the rate of Hawking radiation. In fact, we could pull up the power. We could pull up the power law. Well, I mean, we could work out the differential equation and look at the rate at which it emits light, but it'll basically be gone. The moment you can see it, it'll be gone, right? This guy's doing it for the money from people on the internet who don't know any better. Well, I mean, this makes up like 10% of my income, so it's not like hugely for the money. Not really anyway. I do it because it's valuable. But Odo, it seems like you don't know any better, so you don't have to stick around if you don't want to. From the Tech Gourmet with the €5, thank you. If gauge phases emerge from space-time geometry, can we control deformation of the sorry, I don't know what that sentence means. Can controlled deformations of the metric be used to deterministically generate photon entanglement? So it's not clear that gauge phases emerge from space-time geometry. So there are ways that you can couple space-time geometry to the metric, but keep in mind things like the gauge field exists in an auxiliary space, right? So you can have curvature of the gauge field of the electromagnetic field, for example, while having, is it true that it can, well, okay. So there is a coupling between the electromagnetic field and the curvature of space-time because the electromagnetic field stores energy, right? But setting that aside, they're like separate things. But you might be referring to something else because you're referring to gauge phases. So I'd have to think about it some more and perhaps get some more detail. But generally, we don't have the power to do controlled deformations of the metric anyway. Like, we don't really know how to do that in any significant way. So probably the answer is no anyway. Can black holes go on forever? Hawking radiation is almost certainly real, which means that no, they would eventually evaporate, assuming that the universe keeps expanding forever. What's the best way to contact me? You can contact me through the link tree in my bio. There's a link to, there's like a contact me, that kind of thing. Yeah, we can create photon entanglement. I think that he wanted to do it deterministically, though. How could you tell if you were in a closed time-like curve? You couldn't. You couldn't. You would have no idea. Okay, no, I should rephrase. So if the closed time-like curve is isolated, you would have no idea. But it's not clear if you can have isolated closed time-like curves that don't allow energy to leak in or energy to leak out. And so in that case, it's just not super clear whether those can even exist. Isn't Hawking radiation matter from particle-antiparticle pairs? Sort of, but it's not like the antimatter falls in and the matter escapes. What happens is that you have a particle-antimatter, and by the way, this idea of Hawking radiation originating from virtual particles is kind of a myth, but it's a good way to think about it at least. So the idea is that you have a virtual particle pair spontaneously show up at the event horizon. When that happens, the one that is on the inside of the event horizon, as a result of the space-time geometry, has negative energy, and the one that's on the outside has positive energy. So the negative energy one gets sucked in because it's inside the event horizon, and it causes the black hole to lose its energy, to lose its mass, and then essentially that's carried out from the positive side. You have a doctorate? I do. Yeah, it's a PhD in physics. Have you hydrated yet? I haven't. Oh, also I should check my Cash App because I'm sure Grimlock sent me some. $5 from Grimlock for hydration. Thank you so much. Can you talk about the timescape model? So I haven't read the original papers, at least not in their entirety. I kind of skimmed them. My understanding is that essentially what they're saying is that we're not accounting for the inhomogeneities of the universe when we do cosmology. Because typically when we do cosmology, we kind of assume the universe is fairly uniform. And that if you account for the inhomogeneities, well, then maybe actually that the time will flow significantly differently here than it will elsewhere, like say in a cosmic void. And so that might account for the observations that we made. But this is a very, very small group of people that is pushing this idea. It's not really been accepted by the mainstream scientific view or by the mainstream scientific community. So I wouldn't put a whole lot of, I would be pretty skeptical is what I'm saying. How long will it take for one to have a wide variety of knowledge on complex subjects such as physics topics? Generally about 6 years, get a bachelor's degree and then a master's degree, in like a master's degree, and then you'll be equipped to answer a lot of these questions. As long as you're humble and you recognize when you don't know something, then you could go learn something. Doc, E equals mc squared, then why doesn't energy deform spacetime? It does. Energy does deform spacetime. It does. Yep. My mic is too loud. It doesn't look like I'm peaking. If gravity makes more gravity, does it take energy from source or does it make free energy? So it's an interesting question. We don't really have a good way to describe how much energy is in a gravitational field. Like, there's not really a good way to do that. From Forum Galorum with the $5, again, Fermi worried that the Trinity detonation would set the atmosphere ablaze. Can that actually happen whenever an atomic weapon is used? We now know the answer is no. And they knew at the time that the answer was no as well. After they did some calculations, they had some tiny chance that it would happen based off of like things that they didn't understand, and we know better now. From Z08 with the $10, thank you, as always. If Everett interpretation is true, then it's possible that false vacuum decay actually happens all the time, but we are just as survivors by quantum immortality. Yeah, sort of. Kind of, sort of. Wouldn't a closed time-like curve be kind of like Groundhog Day? It would be, except you wouldn't know that you're in Groundhog Day. Can Newton's laws be applied to emotional energy? No. Can you describe the God particle and the ghost particle? So the God particle is the Higgs boson. Don't dead name the Higgs boson. Just because Peter Higgs died doesn't mean that you get to dead name it. The Higgs particle, the Higgs boson, is an excitation in the Higgs field. So think of the Higgs field like a pool of water. The Higgs boson is like a water wave, right? And the idea of the Higgs field is that when you're walking around inside the Higgs field, if the water affects you at all, it's going to slow you down. And so that's what's happening to the particles that are moving through the Higgs field. they'll be slowed down, and so they effectively gain mass. I'm going to find me a better physicist that don't ignore people. I'm sorry that you are upset, but I can answer your question. But don't be, actually, I'm not going to answer your question because you're being really, really demanding. Answer my damn question. Like, no, sorry, bud. There's, you know, we have 300 people on TikTok and 138 people on YouTube that are currently watching. Sorry. If E equals mc squared, how does light have no mass but still have energy? Yeah, so this is a good question. E equals mc squared is only correct when the thing that you're trying to describe is not moving. But light is always moving. Light can't not move. So it's not the correct equation. You need the full equation, which is E squared equals mc squared, all squared, plus pc squared. Wow, audio quality is so much clearer on YouTube than on TikTok. That is interesting, actually. I don't know why that is, but I guess maybe that's just YouTube. Upper speed limit for solar sails. I guess in principle it's real. Sorry, not real. I guess in principle it's like asymptotically close to the speed of light. Practically not real. Do we know why black holes exist? Well, yeah, they don't have a function for the universe. They exist because that's what gravity makes happen. Gravity makes that happen because gravity pulls things in. And so if you have enough mass, then the gravity pulls things in so much that you get a black hole. So what is the correct equation when you are not moving? Yeah, so I just said that. So E squared equals mc squared squared plus pc squared. And so P is momentum here. So you have to include the momentum in order to get the total energy. The other case being a person at the center of the star, they would see light fall in, and the second observer would agree. It doesn't seem like they would agree the other case of a rocket invader. The center of star. So I'm not sure what you mean. So if you were in orbit around a star, you would not see light fall towards the star. You would not see light, you would see the light actually kind of go away from you, right? Because it's moving faster and it's, you know, the star isn't heavy enough so that the light can orbit it. So I'm not sure what you mean. If absolute zero were possible to achieve, what do you think happens? You're asking me if the laws of physics were violated, what happens? Well, magic, I guess. Could dark matter be made of gravitons? No. Dark matter is cold. And if it was made of well, okay, I guess it wouldn't necessarily be hot if it was made of gravitons, but no. The idea is that it should be made of a massive particle. Otherwise, it would count as radiation, and we know how radiation behaves, and it doesn't behave like dark matter. Do you think that the odds our standard model will be humanity's last model, or do you think in 20 to 50 years we will find a better model? It's a good question. So we're at the point experimentally where we don't really have a good sense of when we will get new experimental data that is in a different regime of like a different regime, like a different energy regime, like genuinely different. Like, you know, we've been shifting the energy up slightly over the last 50 years, but like we haven't gone like orders of magnitude. And I think that we might need that in order to do genuine new quantum physics. Or we need some really, really clever experimentalists that like use like astronomical observations or something like this. If you were at the center of a star, you'd have a much bigger problem given the heat and nuclear reactions going on around you. Very true. Can a black hole sun come and wash away the rain? Yes. I have some struggles, some terminology in quantum mechanics. Is the dagger is the dagger called an operator? No, the dagger is not an operator. In some sense, it's an operator on operators. The dagger is just the Hermitian conjugate. So it just signals that like if you combine the A and you combine the A dagger in a particular way, then you get something nice. As a physicist, what do you believe is the most important and relevant discovery in the last 1 to 3 years for the scientific field of physics in broad terms? I think the observation that the universe's dark matter density or dark energy density or dark energy strength seems to be decreasing with time. I think that's probably the most significant one that we've got in the last few years. You think the universe may be cyclical and consciousness could be a reason the compression happens? I don't know what compression you're referring to. If the universe is expanding and accelerating and everything will be so far away we can't even see them? Why are there blue shifted galaxies and obvious evidence of galaxies colliding? Well, look, so the universe is only really expanding over distance scales where the gravitational attraction between two things is negligible, right? So if there were two galaxies close to each other, then the gravitational attraction will overcome the expansion. From Doug Debug with the $5. Thank you. As space travelers, how do we keep time in relation to other space travelers? Oh, that's not an easy question. I guess you could synchronize based off of position, and then just keep time based off of a calculated inertial reference frame, and use that. And then you would just say, oh well, our onboard clocks are not moving at the same rate as the universal clock, or something like that. That's probably the best you could do. I can't really comprehend the expansion of space. How can space itself grow but not distance? Well, no. So so the distance is what's growing. It's just not growing everywhere. It's not uniform. The energy of a photon is proportional. Oh, that's not a question. Oh, maybe it is a question. The energy of a photon is proportional to its momentum, but the momentum of a box filled with photons, where the box's momentum in kinetic energy is negligible, is not. How come? Wait, so what's the question? So if you have a box filled with photons, in the instant before they bounce off the other side, the total momentum of the system will be proportional to the energy. Sorry, the total energy of the system, discounting the mass of the box, the total energy of the system will be proportional to the momentum. But if the photons are bouncing off around the box, then the box's momentum can't be negligible. I mean, well, it won't be negligible. It'll be essentially, it'll like equalize roughly with the photons. How is it not uniform? Is in space-time a sphere? Well, look, so the expansion is not really happening like in the solar system, but the expansion is happening in the voids between galaxy clusters. Can you explain Brillouin zones and Fermi surfaces? No, that's condensed matter stuff, and I don't know very much about it. Is it true that math is different at light speed? No. Math is math. Is there a limit to how many photons you can contain in a volume? I guess, in the sense that like if you have more than that, well, so it depends on what the energy is. So for a given amount of energy per photon, then yes, there is a maximum amount that you could contain in a volume, because any more and it would collapse into a black hole. But you can always lower the energy of the photons and then put more photons in. Is there still a need for the ISS? Is the current model outdated, and should orbital experiments still be considered as essential? I don't know, but it's cool to have. Curious, when the satellite turned and took a picture of Earth and it showed us as a blue dot, was it looking at past or future? It was, I mean, it was looking at the past by like, a few minutes. Why isn't gravity included in the standard model of particle physics? Because we don't know how. That's the simple explanation. If we suddenly discovered a new fundamental force tomorrow, how would you try to detect it? Well, if we discovered it, that means that it's already been detected, right? From Forum Galorum again with the $5. Thank you so much. Life exists within deep sea thermal vents on Earth. Could this also happen on icy worlds such as Triton or Europa? Any space missions looking for it? I think that we have a space mission that's heading to Europa soon, the Europa Clipper mission. So I think so. I guess in principle that's possible. Thoughts on government intervention in physics? It's not really a thing. I've never heard of this happening. Yeah, gamma rays can produce electron-positron pairs when they interact with stuff, also if they're energetic enough. Yeah, that's true. Speaking of black holes, if quark pairs generate new pairs when pulled apart using the energy it took to pull them apart, does that mean that we can convert all energy of a black hole into mass? The energy of a black hole is already, in some sense, mass, right? Or are you talking about like outside? No, so the whole question of hadronization for pulling quarks apart, all that's going to happen is that you'll have stuff fall into you'll have one of the quarks fall into the black hole and it'll hadronize in there, and then you'll have the other quark hadronize on the outside. And it gets its energy from essentially from the black hole being temporarily color charged. What happens if I put root beer in a square cup? You get beer. Is it possible to survive 90 years in a supermassive black hole? I guess if the black hole are big enough, then sure. But the amount of time it takes to go from the event horizon to the singularity of the black hole is a finite number. It's a finite amount of time. Does reality exist without anything to perceive it? That is a philosophy question, but probably, yeah, it seems like it should. If dark matter weakens, would that mean that space between planets would grow as galaxies slowly separate? If dark matter weakens. So dark matter is not really relevant to, say, like the orbital paths of the planets in our solar system, nor is dark energy for that matter. The sun is just the dominant gravitational effect. Not sure what else you mean. You being a physicist, would you argue that all science is physics? No. Could two objects too large to be considered quantum be held in superposition? Well, if they can be held in superposition, then they're not too large to be considered quantum. I mean, the thing is quantum mechanics stops being quantum mechanics and starts being classical mechanics when you have big things or hot things or wet things generally. But if you make a big thing cold enough, then in principle you could have quantum superposition. In fact, there was a really interesting experiment done, I don't know, 10 years ago or something like that, where they actually put something in a quantum superposition that was macroscopic. It was like tiny. You could hardly see it, but it was big enough to see with the naked eye. But wouldn't the new pair inside the black hole also get pulled apart? Wouldn't that chain reaction, why would it get pulled apart? They would just all go towards the singularity. Oh, it says that I am not active. Doc, how far can the periodic table go down without being impossible to be stable even in the smallest times? Yeah, so we don't know. There are some questions about whether it makes sense to even talk about things being atoms beyond about 172, atomic number of 172. There's also a time limit. We stop calling things elements if they can't be stable for at least 10 to the minus 14 seconds. But we don't know. I mean, like, these are really, really hard calculations to do generally, so we just don't know where the limit is, practically speaking. What's the difference between mass and energy? Mass is what we call it when it has the energy, even when it's stationary. Hi, doctor. Law of attraction and law of vibration. Is it real? Does it work? No, not real. Doesn't work. Made up. Fake. I am a biologist and not a physicist. Why is math hard? Good question. Why is math hard? Do liquid hydrogen drops from the walls of the container? What? What about the stable island at the 126 or what? Yeah, so there is this idea of the island of stability on the periodic table, which is that, so let me back up and say that, you know how like around nuclei there are magic numbers of electrons, like the helium is a noble gas, it's super stable, it doesn't form bonds because it has 2 electrons, and 2 electrons is like, it's like super stable. It's a magic number for the number of electrons. And then 10 is the next one. You add 8 more electrons, and now you get another thing that's super stable. So there are shells, and when the shells are full, they become super stable. Now, in a nucleus, there are also nuclear shells. Now, it's a little bit more complicated than the electromagnetic ones for the electrons, but there's still nuclear shells. And so we say that there are magic numbers of neutrons and magic numbers of protons in nuclei. And it turns out that at around the 124, 126 or so, number of protons, and then 180 or something like this number of neutrons, those would both be magic numbers. And so we would expect that you might get extra stability even at those extremely heavy elements that are more stable than the elements before or after it. And so the idea is that maybe there will be like a small island of stable elements, or at least more stable elements, which people are working on. It's just really hard to do this because making heavy elements is really hard. If a neutrino passes through light, from my perspective, the light would be straight. If a neutrino passes through light, I don't know what that means. But from the neutrino's perspective, bent. But from the center of a star, I still don't understand the question. Maybe I need a diagram. I mean, the point is that you just have to consider what's happening from the observer's perspective in each different situation. And that it might be different, it might be the same, depends on what the observer's doing. From Tommy Cat with the $2, were you forced into this field or gravitated? Funny, but no, I just love it. And thank you for the $2. What is meant by a gauge boson? How do they cause interactions? So a gauge boson is a curvature. It's not quite a curvature. It's a potential field for a particular type of geometric object called an auxiliary field. And when you have curvatures, the potential source curvatures in the auxiliary spaces, sorry, not auxiliary fields, auxiliary spaces. When you have curvatures, those curvatures change the way that you take derivatives, right? And derivatives are what tell you how things are moving. And so if the way that you change, if the way that you take derivatives is changed because you have some curvature, like a gauge that arises from, say, a gauge field, then that means that you would expect a thing to travel in a path that otherwise wouldn't be straight, for example. And it's because of this that we can say that these gauge fields can cause changes in motion. Is energy really conserved? Locally, yes. Globally, it's not even well defined. Has AI done any heavy lifting lately in physics? I don't think so. What are some of the best quantum systems to build a qubit from? I don't know. I'm not involved in quantum computing at all. Is it possible that dark matter is an elastic gravitational force, i.e. the universe expands to a certain point, it will collapse to the Big Bang and repeat? I mean, is it plausible? I don't think so. You'd have to provide some evidence in order for it to be plausible. Do we know why the universe is expanding non-uniformly? Is it being countered by local system of gravity? Yeah, that's exactly it. Will the island of stability be sufficiently more stable to be practical or still very unstable? That we don't know. We just don't know. We don't have enough information yet. Can you explain leap year? Yeah, so a year is not 365 days. It's about 365 and a quarter of a day. So every 4 years, you get an extra day. So that things still line up. If space itself is expanding at a higher rate than speed of light, how do we see distant galaxies? It's not. Space doesn't expand at a speed. It expands at a rate. And the rate is not a speed. It's not comparable with speeds. It's not comparable with meters per second. It's a doubling time. It doubles in size every 10 billion years or so. Could you electromagnetically capture a black hole, since electromagnetism is 10 to the 40th stronger? I suppose in principle, but the black hole would have to be charged, which is hard to get. Is gravity a wave or a constant pressure? Well, it's not a pressure. It's also only sometimes a wave. It's a curvature of space-time. Where is gravitational potential energy stored in GR, and how is it measured in a tabletop setup? So gravitational potential energy is not even really a thing in GR. It's not like a thing. Sometimes you can kind of define something so that it behaves like there's potential energy, but in general, it's not a thing. Tommy Cat with the $2. Do you think AI theories are legit worthwhile? I don't know what you mean by AI theories. Oh, if you mean like physics theories generated by AI, no, they're almost always worthless. From Erica Zuniga with the $2. Do you like death metal? Generally, no. Could a black hole be useful in terms of power generation? Yes, there's something called the Penrose process. Of course, Penrose. That allows you to basically take the energy associated with the black hole's spin, with the black hole's rotation, and kind of extract that energy. And you can essentially get energy out that's like 23% of the mass of the stuff that you throw in via E equals mc squared. So it's very, very efficient. I tried to do a $2 super chat, but it wouldn't let me. I only do $5. Well, thank you, Aloysius. And Dylan, thank you for becoming a one month member. I think that's what that is. Thank you. I appreciate you. Does the universe expanding not create new matter? No, it doesn't create new matter. I know you're a physicist, but what's your favorite chemical reaction mechanism? I don't know a lot about chemistry. I just don't. What do you think about Stephen Wolfram's computational universe model? I think it's kind of cranky. Like I don't think anybody's really taking it seriously, and I'm not really taking it seriously. Are you answering questions that aren't in Super Chat? Yes, but Super Chat gets priority. For obvious reasons. Why wouldn't a star be considered a white hole? Oh, it's just not geometrically the same thing. It has inward pulling gravity. White holes don't have that. What do you think of the current state of universal determinism? I was a quantum computing researcher for some time, and my understanding is that the universe fundamentally behaves non-deterministically. So you can only get determinism if you, the non-deterministic behavior of the universe is only true in some interpretations of quantum mechanics. In other interpretations, you can still get a deterministic universe that is identical from our perspective to a non-deterministic universe. Can gravity have a gauge boson particle associated with the force of gravity, or will it never join quantum mechanics and remain in relativity? People thought for a long time that it could, but it seems like people have struggled to make this happen, and it might even be impossible for it to make sense at the level of quantum field theory. How do you decide which papers to take seriously or not? You read them. Right? Or at least skim them. What are your thoughts? Oh, I should hydrate again. Oh, by the way, if you guys want to support me, there's a few ways to do this. Oh, by the way, actually, I should mention this. I'm launching a thing. So today I am officially launching the thing. And this only applies to people who are like independently wealthy. Please don't do this if you're not independently wealthy, if you haven't made a whole lot of money in your life and you just don't know what to do with the money. So I'm launching this thing. I'm going to make it on Patreon. I haven't decided on the exact number yet, but essentially I'm going to let you pay for, let you fund my research. So I do research, and I'll give you the opportunity to basically give me money to get your name in the acknowledgement section. You'll also get updates on the research papers that I'm working on. You'll get info on when I'm submitting it, and so on and so forth. But this is essentially a way to be like a medieval patron for a scientist, because that's what used to happen. And we don't do that anymore. And I think that it's a fun idea. It will be a lot of money, because your name will be in the acknowledgements, like your full name, if you want it to be. I'm thinking on the order of like several $100s to like $1,000 or something like this. I haven't decided on what number is the right number yet, but it will be like a month. It will be very expensive. So only do it if you have a ton of money and you want to support physics. But anyway, so that's the thing that I'm going to be launching. I'll send out an announcement in the Discord server later once it goes live. Obviously, nobody has to do it. I'm doing the research anyway. But if you want to support it, that is a way to do it. Anyway, let me go back to answering questions. No, this is just supporting my paper, like all of the papers that I write. If you are a medieval patron while I'm writing the paper, you will go into the acknowledgement sections. That'll be essentially the reward, if you will. Why does time warp when traveling near the speed of light? It doesn't warp. It just changes, right? Like it's still linear in some sense. It's not like curvy, but it just, the amount of time that the amount that you're paying through, the amount that you're traveling through time decreases as you travel through space more. Can you buy me printer ink? I don't really use a printer. Is this like a pay to dox service? I guess in principle you could dox me, but if you're willing to give me like a large sum of money to get my like full name and research and stuff, then like, I guess. Begging? I mean, it's not begging. I'm doing the research anyway, but some people want to support me. So why not give people the option? I mean, people have asked about this. Do you think we will ever figure out the purpose of a black hole? I don't think, it's weird to think that they would have a purpose, right? I don't think that they do. There are things that exist in the universe. That's just the way that our universe is. Why is the non-deterministic interpretation of quantum mechanics mainstream? Oh, it's just the easiest to teach, probably. What are you currently researching? So currently I have a few projects. I have one project that's been going on forever, which I really need to finish. That's on, it's a thing called a Carolean. It's related to a Carolean manifold. It's a type of geometric object or it's a type of geometric space that kind of models black hole event horizons. There's a paper that I'm working on, I'm just starting to work on, involving kind of doing a quantum gravity version of Hawking radiation, modeling those. There's a paper I'm working on that is involved with describing Einstein spacetimes in terms of their integrated conformal invariance. It's kind of a technical math paper. There's a paper that I'm working on that I'm going to submit soon, actually. That is a non-existence proof for a particular mathematical object. There's another paper that I'm working on that involves studying the conformal invariance of higher codimension submanifolds. So there's a lot of things that I'm working on right now. Has your model on the infinite universe been approved yet? It's under peer review. It takes a pretty big chunk of time. How often do you start a paper and scrap it since it isn't going anywhere? I haven't done that yet. Well, okay, there's one thing that I was doing that it just did, like, there was a set of calculations that me and a colleague were doing that were good calculations, but they just didn't fit in any papers that we were working on. So they're kind of just sitting there waiting for us to use them somewhere else. What do you actually have to finish? Like, do you have to do calculations for some things? If so, how? Would love to hear the nitty-gritty. Yeah, so For the first paper, the one that involves Carolean manifolds, so essentially it's written up, but me and my two co-authors, we were going through the paper and I found an error. And so we have to make sure that that error doesn't propagate. And we have to make sure that if it does propagate, we have to fix all of the places where it propagated through. And then we have to go in and essentially do a read through, like make sure that it's well written, that we have all of the right citations and things like this. In principle, it's not a lot of work to do, but one of my co-authors literally just had a child, and the other co-author recently got his funding cut because he worked at Brown, and Brown had their funding cut from the federal government, so he lost his job. So it's not because we're stuck. It's because personal reasons have basically gotten in the way with these this project. It's been going on for about a year. So it's just one thing after another. Like so anyway. Anyway, of course you don't research about UFO and dare demanding extraordinary evidence. Physicists are clowns. Yeah, it's not particularly interesting to me. Why would I spend time working on something that's not interesting to me? How do I get into working in particle physics? What degree field should I go into that involves it? Get a PhD in particle physics. That's the way to do it, right? Talk about quantum computing. I have a few videos on it, but it's not something that I know a lot about. Like, I know more about it than the average person, but it's not my area of expertise. From Joe Pro with the 200, are those Indian rupees? Do you think it would ever be possible to send information faster than light, faster than the speed of C? If so, could we send information to past future? I suspect not, no. Can you explain gauge symmetries in other than EM? So just think about EM, but the gauge symmetries are more complicated. They're just not, if you will, they're not abelian. That's just the word. How is negative energy, exotic matter, created? We don't know. We don't even know if you can make it. We don't even know if it's possible to exist. You think the universe may be cyclical and consciousness could be a reason for the decreased entropy? No, I don't think that consciousness has anything to do with anything. You should stream the stuff you're working on. Would love to see how you do the math, how you calculate stuff and why, all way above my knowledge level. I've thought about it. The trouble is that on every single paper that I'm working on, so first of all, some of it I do by hand. Oops. Like, here's a notebook. This is a, for the new paper that I'm working on that I'm hoping to finish this week. Here's the notebook, right? I was working on it by hand. I was working out some ideas. There are some failed ideas. Let me show you a failed idea. Yeah, so you'll see. Try to prove without that claim. Right, because I did manage to prove something, but it required a claim that I just don't think was true, so I abandoned that route. So a lot of it's done by hand on a notebook like this, and I have a stack of notebooks all filled with research. The other thing is that when I'm writing, when I'm doing calculations on my computer, my name is visible, and I'd like to remain or keep some degree of privacy, right? At least if I'm live streaming where anybody can see it. Someone is speaking at my college about flat Earth. Well, I got to debate a real flat Earth today. Real flat earther today. That sounds fun. Scientific theories are collections of facts that form an explanation of a natural phenomenon. Yeah, that's true. Could the container for a cold fusion reactor be magnetism? I guess, but cold fusion is not a thing that can work. If you had to bet money on a law of physics that is truly fundamental, which would you pick? Not the second law. Not the second law of thermodynamics. I would probably pick, I don't know if it counts, but Noether's theorem, that symmetries give rise to conserved quantities, right? But that's a theorem, so, I don't know if that counts. Other than that, yeah, I don't know. What discovery in your field would excite you the most in the next decade? It happened last year. The discovery that dark energy might not be constant. From John with the $5, which speculative technology in Star Trek seems most unlikely? Subspace, anything subspace related. What kind level of math do you use in your actual physics research? In the physics research, it's generally just differential geometry and like a little bit of maybe functional analysis. In the math research, it can get more sophisticated. I can use things like tractor calculus and so on, but yeah. Have you ever run one of your papers through AI to see if it's improvable? I have, and it didn't give me good suggestions. Although for the paper that I'm working on now, because it's a solo paper, I probably will run it through AI just to see if I've made any typos. From Juiced, sure, with the 10 British pounds. No question, just supporting science. Go science. Thank you so much. That means a lot. You guys are so sweet. If a four-dimensional being were dropped into a 5D universe, would they still experience in 4D and why? Yeah, I suppose they would. You suspect what is no? No, we can't information faster. Yeah, no, I suspect that we cannot transmit information faster than the speed of light. I don't have $5 for you to answer my question. I tried $2, but it's long. Let me see if I can just see your question. I don't see your question anywhere. At some point in history, wasn't there a point where all of space was a habitable zone, and for how long? Probably not. Well, okay, maybe. I guess there was a point in time when the universe was like, 20 degrees Celsius. I guess we can figure out when that point in time was. Let's do that. Let's do that right now. So first, I need to know how hot was the CMB when it was released. So the CMB was orange, and I think it was like, okay, it was around 3000 Kelvin. So we need around 300 Kelvin. So we need to decrease the CMB by a factor of 10, the CMB temperature. So that means that the universe needs to expand by a factor of 10. And if the US is going to expand by a factor of 10, that's more than it was 380,000 years after the Big Bang, then we need to look at Z equals about 100, because the redshift factor at the moment of recombination when the cosmic microwave background was emitted was around Z equals 1000. So we just want to go look when it was that Z equaled 100. So let's just use a cosmology calculator redshift. There's a few of these that are fairly good that use modern data. So there's one made by Ned Wright, which I like to use. So if we plug in Z equals 100 and we just use a general flat metric, what we find is that it was the age at redshift Z was about 16.6 million years. So this is about 16.6 million years after the Big Bang. The universe was hot enough to support, or was warm enough that water could just be comfortable. However, I suspect there were no planets, so wouldn't have really mattered. And it would have cooled down very, very quickly, right? Andrew Michael with the $2. How do you explain the US Nimitz Tic Tac UAP? I don't know. It's unidentified aerial something or other, whatever UAP stands for. It's unidentified, so I don't know what it is, but I suspect it's probably something fairly benign. From Earn It with the $5, why can't we use quantum entanglement for FTL communication? Yeah, so there is something called the no communication theorem, which essentially forbids it. Essentially, you can't transmit information via entanglement. Even if entanglement is something happening at FTL, there's nothing that you can do that doesn't require slower than light communications to be able to use that information to learn to gather information from the entanglement. Unidentified aerial phenomenon. Isn't it unidentified aerials? What does UAP stand for? Oh, I guess it is phenomenon. Okay. Cold fusion when two protons. Oh, that's not a question. Do you think time is something real that exists on its own, or is it just something humans invented to measure change? Well, certainly it's something real. Like, it's something that bends. So it's definitely something real. The question is it fundamental or is it emergent? And that I don't know. Aloysius Mitchell, thank you for the $2. I appreciate you. Would 4D be time, but 5D be actually age? Like how 0D is basic existence, but 1D gives it direction? No, so I think like, dimensions are just directions that you can go in. Now, you can travel in 3 spatial directions. There's up, down, left, right, back, forth. And you can travel in 1 time direction, forward. 5D isn't age. That would just be another either temporal or spatial dimension that you could travel in. Could you explain what a black hole star is? So there's a lot of things. There's like gravastars and... Let me make sure that I get it right. Are we talking about okay, so quasi-stars is what you're referring to. So these are things, yeah, okay, I know what this is. So this is basically a kind of the idea of like super, super bright stars that were essentially powered by black holes at their cores in the very, very early universe. That's roughly the idea. Now, we don't know that they exist. It's a hypothetical thing. I do have a video on them from a while ago, though. You have guilty eyes, like you have something to confess, so do it. I have guilty eyes. Chat, do I have guilty eyes? What would it mean to travel up, down, left, right in time? Well, you would have to have more than one time dimension. I might have tired eyes. I woke up at like 1:30 and then I woke up every hour on the hour until like 4:30. Where on the lobe scale do you place 3i Atlas? Is high on the lobe scale mean that it's actually aliens because it's a comet? It's a little bit of a weird comet, but it's a comet. Confess whatever I did. I did it. I did it. I forgot to unload the dishwasher. Why is there more matter than antimatter? Because if there was more antimatter than matter, we would just call that matter. No, but there's a more serious question, is why aren't they balanced? And that we don't know the answer to. That is one of the bigger unsolved questions. Do you always sleep like that? No. It's probably because on the one hand I'm getting sick, and on the other hand I'm still recovering from the time change flying back from Europe. Because I landed in Europe on, I mean, it's already Wednesday. I should be adapted, but I'm not. I'm not adapting for whatever reason, so. From Fear's interaction with the $10, thank you so much. With whom would you be more likely to succeed educating about climate change? A group of random MAGAs or a group of random 17th century peasants? Definitely the random 17th century peasants. There's no reason to think that they wouldn't believe me. I hold a magic rectangle that tells me answers. Why wouldn't they believe me? I'm a sorcerer. Where in Europe? I was in Brno in the Czech Republic. You cut out on my question. Can you please repeat your answer? I don't know what your question was. Oh, what would it mean to travel up, down, left, right in time? Yeah, so to travel up, down, left, right in time, you would need another dimension of time. Right now, we're essentially traveling forward in time. If you want to travel left, right in time, then you would need another dimension of time, right? Does light have mass? It does not. Light does not have mass, no. Why is time considered fourth dimension? Well, it's one of 4 dimensions. There's not really an ordering of the dimensions. From Fatshul, that's an interesting name, with the 5 Canuck bucks, do you have any thoughts on Malcolm Bendel's work with zero-point energy plasmoids and the thunderstorm generator? I have no idea who that is. I haven't heard of any of it, but just from the stuff that you're referring to, zero-point energy plasmoids and the thunderstorm generator, it sounds like hogwash. Like it just does. How important is it to have a good PhD advisor? So there's 2 factors that go into a good PhD advisor, maybe 3. The first is how famous are they? If you want a job in academia, having a famous PhD advisor is important. Unfortunately, that's how that is. Second factor, how good are they actually at being a teacher? Like, they are going to they're going to be teaching you for like 3 to 5 years, right? So you want them to actually like, you know, be interested in devoting the time to actually like teaching you to be a researcher. The third thing that I think is actually like criminally underrated when it comes to selecting a PhD supervisor is how well do you get along with your PhD supervisor? Because again, you're going to be spending a lot of time with them. So it'd be good if you get along well as friends, colleagues, whatever. Can you explain what physics is in just a couple sentences that anyone can understand? Physics is, one sec. I made a video about this a while ago, and we don't have to listen to the whole thing, but it's pinned on my TikTok account if you want to listen. Physics. Physics is the study of the smallest things in the universe, and the study of things bigger than you can imagine. Okay, so I'm actually not going to do that because it's a long video, but physics is the study of structure, it's the study of matter, it's the study of motion. That's the way to think about it. It's the study of fundamentals as well, like the fundamental rules of our universe. From JoPro with the 100 Indian rupees, sorry to repeat the same question again, but I'm writing a book and need a semi-realistic sci-fi way to send in info faster than light, just inspiration. Well, there are no realistic ways to do that. Actually, what you could do is talk about a warp bubble. Talk about a warp bubble and then have couriers. Have like a Pony Express, but using warp engines. That's a way that could work. Now, warp bubbles are probably not possible to make because it requires exotic matter, but you can just shove that under the rug. And from Fear's interaction again, pro tip when teaching 17th century peasants, don't show them your smart device if you don't want them to show you their gallows. Look, I have a magic square that gives me answers. Why would you not want to listen to me? It's very vague. Can you explain more? Yeah, well, look, the thing is physics is the study of, it's the study of matter and motion, right? And then all of the things that entails. Is there any good intuition for what momentum actually is? Yeah, it's how hard something, it's how hard it is to get something to change its motion. Or another way you could put it is, how hard is it to get something how hard is it to get something to stop moving? Is it true that physics is in a dead end, and why it's because of the secrecy and stigma around UFO? Nope, physics is not in a dead end at all. And look, if they wanted scientists to do UFO stuff, then they would just actually release evidence rather than just holding hearings where people say, oh, I can't tell you, but I definitely saw it. And then from $2 with Tommy Cat, can you defeat four 17th century peasants in combat? Probably not. I'd probably lose. Thoughts on 3i Atlas? It's a comet. It's a comet. Why does CERN have a Shiva statue outside? I think the Indian government donated it. Do you do much computational physics or any simulation work, or just pure pen and paper theory? I don't really do any simulation work, no. What are some advanced statistical concepts that translate into physics? I don't know. I'm not good at statistics. I mean, I'm better than the average layperson, but I'm not good at statistics, and I don't do statistical mechanics. So, what if the only white hole is the Big Bang and all black holes bend time all the way back to the beginning? So the Big Bang isn't a black hole. This dude, not a physicist, he unemployed on TikTok every day arguing about God. Well, so first we can just look at the facts of the matter. So I did one atheist debate on the 15th, that was 2 days ago, and then I did another one on the 4th, so that was 11 days prior. So it's definitely not every day, right? On the other hand, a physicist, I would call a physicist someone who has the occupation of doing physics. And considering that I spend 5 to 6 hours every day working on papers and research and, you know, doing peer reviews and things like this, and publications, I think that that qualifies, right? Now, if you have a problem with the fact that I do live streams, then that's on you, bud. And what are they using the advanced alien tech for? No one has conquered the world with advanced tech, although I haven't been outside. Oh, okay, that wasn't a question for me. What is dark matter? We don't know. Dark matter is some kind, it's a theoretical explanation for what is causing things to seem like they have more mass than they look like they have mass. And so the idea behind dark matter is that there's just some stuff that we can't see, like invisible stuff, basically, that has mass but doesn't interact with light and hence is invisible. I want to do a comic book with Dr. Blitz as a physics superhero that looks like you. Would I have your blessing? Yes, but take away the doctor and just have the superhero name just be Blitz or something like that, just because it sounds cooler. Or maybe not, I don't know. Can electromagnetic propulsion be a thing? I've thought about this for a while. Yeah, light sails are a good example of electromagnetic propulsion. What's your thoughts on the neutron lifetime puzzle? Yeah, so I don't actually know. I made a video about it a while ago. I don't know. I have no idea. It's very, very bizarre though, isn't it? So for those who don't know, the neutron lifetime puzzle is basically this idea that, well, first I should give some background. Neutrons, fundamental particle, we know, or they're not fundamental particles, subatomic particles, they live in the nuclei of atoms. But you can pull neutrons out. Sometimes neutrons just kind of fall out of nuclei, neutron radiation, if you will. And when that happens, when the neutrons are no longer stuck in a nucleus, they are not stable. They decay in about 10 minutes or so. They live for about 10 minutes. The trouble is, the amount of time that they live is different depending on whether they're stuck in a bottle or whether they're traveling in a beam. And as far as we know, we have no explanation as to why they have different lifetimes depending on how you're measuring their lifetime. We just don't know. And yeah, it's really weird. How does peer reviewing work? Well, you get an email from a journal. So I got an email. I should probably respond to this, to be honest. I got an email from a journal a while ago, like a week ago, on September 5th, saying, hey, here's this paper that got submitted to our journal. We think that you would be the appropriate person to review it. You have the relevant expertise. are you willing to do so? And then I either say, yes, I am willing, and then I do it, and I have a few months to do so, or I say, no, I'm too busy, or I'm not interested, and so I don't do it. That's how it works. And then you read it, and then you check if it's right. What's more important to mathematical physics, representation theory or probability? I would bet representation theory. Where are you on string theory? I don't think string theory is the correct theory for our universe, but I think it's the correct theory for some universe. Sorry, I have to pop my neck. Do you get paid to peer review? No, it's volunteer work. How do MRI physics work? It's been a long time since I've looked into this, but if I remember correctly, essentially what they do is they bombard you with radio waves, or radio waves essentially. Or do they just use the magnets? Is it radio waves or do they use them? Anyway, so they do something with magnets or something with radio waves or something like this that basically makes the electrons in water, I think it's water, sorry, the hydrogen atoms oscillate in a particular way. And then they have detectors that basically look for the emissions from those oscillations as they kind of settle down. And when you do that, you can basically see where those certain things are, where like the water, the protons, whatever it is. I probably got some of that wrong, so Google's probably your friend here. But essentially what's happening is you have some excited molecule or proton or something like this that you excite, and then you look at the emissions that come out. Different tissues have different rates of relaxation. There you go. Yeah. Why Dr. Blitz, you're a Blitzcrank man? No, that's a story that I'm not going to tell. Would you rather live in a world with no friction or no light? Oh, they both sound awful. How much topology? Do you use much topology in your work? Occasionally. It's not like the main thing that I do, but occasionally. Why do you think string theory is wrong? Well, string theory requires supersymmetry. And like, supersymmetry just seems to not be a correct thing for our universe. Could low energy fluctuations in an external universe explain spontaneous Big Bang? I suppose there's this idea of a universe from nothing that Alexander Vilenkin puts forward. I'm not so sold by it, though. What do you use, topography? No, I use topology. So topology is kind of the study of shape without size, shape without angle. So think of the difference between a donut and a sphere. A donut has a hole in it, a sphere doesn't. And so topology shows up when doing some differential geometry because you can end up with topological invariants that, well, anyway, that's roughly why. You know how guitar necks bend? Maybe lots of vibrating strings bend space-time, so gravity with no gravitons. I'm skeptical. Isn't the neutron decaying at a different rate in a beam because of time dilation? No, that's not why. That's been accounted for. That's not why. From C-bar with the $2, can you compare and contrast energy and force? Force is the thing that causes change in motion. Energy is a quality of motion. It's a quality of a system that in part at least can capture the motion. So force is a thing that does something. Energy is a thing that describes something. I don't even know the difference between a donut and a coffee cup. Me neither. That's a lie. I do know the difference because I'm a conformal geometer, not a topologist. You say physics is not in a dead end, but we still use rocket propulsion when we do have evidence of UFOs using another type of propulsion. Okay, where's the evidence? Show us the evidence. And grainy footage is not enough. Show us the actual evidence. Give us the physical evidence. Show us the captured drone or the captured UFO that actually behaves in this way. Give us the actual evidence, not just some sketchy videos where we can't tell distances, we can't tell speeds. From Magnify with the $5, I've heard German and Polish may make physics easier to discuss than English due to inflection and clear verb aspects. Have you seen any evidence of this? I don't know. I don't know German or Polish, so I don't know. Could you give a brief breakdown of why sim theory is unlikely? Well, look, so there's a question of like, well, what if the simulation is happening in a universe that's nothing like our own? But then you're just speculating. There's no reason to think that that's the case. The original reason why this was put forward as like a plausible idea is because the thought was like, well, it doesn't seem so far-fetched that we would be able to simulate a universe like our own. So if we were able to simulate a universe like our own, then it seems plausible that we in fact are a simulation by something like our own, like ourselves. But it turns out that there are inherent physical limitations that would prevent us from, oh, I think I have a meeting today. Oh, it's at noon. Okay, that would prevent us from simulating a universe like our own, which kind of rules out this idea that we could simulate a universe like our own, which kind of makes the idea that we are in a simulation less likely. Yeah, I should actually end the live soon because I have a meeting soon that I forgot about. All right, y'all, I'm going to end the live. We've been live for about an hour and 40 minutes. Thank you guys all so much for being here. Remember, I'm going to send out an announcement on my Discord server about this this new medieval patron style Patreon thing. So expect that later this afternoon if you're interested in it. And yeah, I'll see you guys tomorrow for some more debates, as long as I don't feel